Welcome, students, to the lecture on the experimental research strategy for research methods. I'm going to break this lecture down into smaller parts. In your syllabus, you can see that this lecture on the experimental research strategy appears in two parts. But instead of having part 1 and part 2, I'm going to have part 1A and B and part 2A and B, because there's a lot of material in this particular chapter. This is associated with chapter 7 in your text, and I want to be sure that we go through it thoroughly so that you understand it, because in my opinion, this chapter, along with chapter 12, which is the correlational research strategy, are really the meat and potatoes of the course. In particular, the experimental research strategy. Experimental approaches are considered the gold standard in science. And as you know from previous lectures, that's because they allow you to draw cause and effect conclusions. And so for that reason, I'd like to take our time and go through this thoroughly. And we will do that, but not before you laugh at my little cartoon I have here. Control groups are unique to the experimental method. You don't have control groups really in any other methods other than perhaps quasi-experimental methods, but in that case they even really aren't control groups, they're just comparison groups, but we're going to get to that in a moment. And you don't have them in correlational design. So here we have the control group and here we have the out of control group. So I thought that was kind of relevant. The other thing that you should know is that very often students have misunderstandings about control groups, which, as I said, are present in the experimental method. But are they present all the time? Is a control group a requirement of an experiment? Take a minute to think about your answer to that question, if you will. In what you've learned about experimentation and experimental methods in past courses, or even in this course, do you believe that a control group is necessary? Yes or no? What do you think? Well, the answer to that question is no. A control group is not necessary. All you need is a requirement called comparison, which a control group would provide. But a control group is not the only way to meet that requirement for comparison. And we're going to talk about that and why that is in the next couple of slides. But before we begin, I want to remind you a little bit about that article that we read by Frick, Horbury, and Gutentag on lexical retrieval and free recall as a consequence of hand gestures, if you remember that discussion in lab. And I'm going to draw out for you the design of that experiment simply because I'm going to be drawing for you sort of a layout of these different research designs that we're going to be talking about in this unit, and I want you to kind of get used to how I do that. Lots of people lay out experiments visually a little bit differently. This is just the way that makes the most sense to me. So in that case, and this pen is very shaky, so I apologize for that. In the case of the article on hand gestures and their effects on lexical retrieval and free recall, if you remember, we had one independent variable, and that independent variable was hand position. We'll call that hands. Okay. Now, that was the independent variable. Sorry, the TA is calling. Hold, please. So that was the independent variable, one independent variable. And that independent variable had two levels, right? In other words, remember the definition of a variable is something that changes quantitatively or qualitatively over two or more levels. So what were the variations of hands? Hopefully you remember that. One variation was that one set of participants had their hands free, right? And one set of participants had their hands restricted. And remember, they had two different experiments that they ran. I'm just going to abbreviate that, REST. Okay? Remember, they ran 2 different experiments there. In the first one, the hands restricted group, they were holding a bar, remember? And they found that that was too distracting. They didn't think that the recall was a robust sample of what the participants really could remember because they were too cognitively distracted by the bar. So they ran the study again with the hands in the apron, which was not as distracting. Well, either way, they were just using a little bit different methodology. They were still using 2 treatment conditions, which represented the 2 different levels of hand position, which was the independent variable. So they randomly assigned a certain number of participants to that group and a certain number of participants to this group. And let's just say, for the sake of argument, they had 20, a sample of 20. Let's see, participants 1, 2, all the way down to participant number 10. And then in the restrained group, they had participants number 11, all the way down to participant number 20. Okay, so for the sake of argument, because I don't remember how many participants they had in the methodology discussed in the participants section of that article, let's just say they had 20. So they randomly assigned them to one of 2 treatment conditions. Okay, they put 10 people in, hands can be free. They put 10 people in, hands had to be restrained by the apron. Okay, so they run the experiment. They restrict these people's hands. They let these people's hands go free, and they count the number of words they recalled, which was the dependent variable, right? So at the end of that experiment, basically the rationale here is that they will find the mean number of words recalled for the free to gesture group, the mean number of words recalled for the hands restricted group, and then the hypothesis is that they are looking for significant differences between these 2 means, right? So mean number of words recalled, or number of words recalled, is the dependent variable, or the outcome variable. Now, I'm going to be referring back to this research design throughout this lecture and throughout parts 1B and parts 2A and B. So I just wanted to get you sort of used to that by thinking back to this experiment with which you are all familiar. All right, so here's the agenda as usual. I don't know why I have the slide in here, but I do have a couple of housekeeping things I want to talk to you about. And then we do have some objectives for this chapter. And then, of course, the overview of the lecture. And then assignments are just reading the chapter and doing the lecture listening checks, although there is not one scheduled for this part, but there is for part 2. So be looking for that. All right, so here's the housekeeping. What is coming up for you, if you look in the syllabus, is conferences. And I'm planning to schedule virtual conferences with each of you individually so that we can talk about the status of your project. I feel like I need to touch base with you because having 24 different projects running simultaneously, I need to keep a thumb on where everybody is at in the course of their project so that there's not going to be some glaring error that causes you problems down the road when you go to present your project or analyze your data. So just be aware, check the syllabus for the week that is coming up because I'm devoting a week to that where you'll let me know your availability. And then I will respond back during one of those times that you're available with a link to a virtual meeting so we can discuss your project. So that is going on during that data collection, data entry, and conference week. Look at your syllabus to see what week that is, okay? The other thing that's going on during that week is data acquisition. Okay, what does that mean? That means you're collecting the data for your project. Now, you guys have a couple of options here. One is that you can actually collect data on live participants if you choose. However, because of COVID, you're going to be required to do that as an online survey. I am not a whiz or even remotely knowledgeable about online surveys. So if that is what you wish to do as far as formulating and setting up how that's going to function, you're going to be on your own. I can look at the questions. There are opportunities where you will be submitting drafts of your questionnaires to me so that I can make sure, you're asking reasonably good questions in order to measure your variables. However, if you want to set something up to capture actual human participant data, that will be something that will be left to your technology knowledge. Now, having said that, also be aware that if you are going to collect data on actual research participants, by this point, you already should have been looking at going through the human subjects review process. That was addressed back in Lab 9. So if you did not contact me then to talk to me about collecting data on actual human participants and you still want to do it, you better get a move on because time is running short. In fact, it might be kind of sketchy at this point for you to do that. If you did not go through that process, then you will be using a fabricated data set, which is often referred to as a dummy data set, in which numerical values are just made up, but you go through all the analysis and data entry just as though they were actual human participants. If you're going to go that route, you're going to be required to have a minimum of 25 questionnaires completed that you'll have to complete yourself. Or you can have friends help you with it, or whatever it is that you want to do. You just need 25 dummy data sets, especially if you're doing a correlational design. If you're doing an experimental design and you have treatment conditions, you want to maybe shoot for 30, because that way, if you have 2 treatment conditions, you can have 15 participants in each condition. And if you have 3 treatment conditions, you can have 10 participants in each condition. So keep that in mind as we're coming up to that week of data collection, data entry, and conferences. The other thing that you're going to be doing during that week, since we don't have lectures and we don't have lab, is data entry. So once you've made up that dummy data set, you're going to have to put the data into SPSS or PSPP. That is also discussed in lab. So as long as you're following along in the labs, you should be pretty good to go. So sometime prior to Lab 13 is when you should have your dummy data set created, because it's in Lab 13 that we're going to do the analysis. So just some important things coming up. Another important thing coming up is that your method is due soon. Again, check the lab guide for that particular due date. When you submit your method, a draft of your measures are required. So whatever tools you're using to measure your dependent variable, if you're doing an experiment, or your 2 variables, your X and your Y, if you're doing a correlation, and any demographic items that you want to use to describe your participants in your participant subsection of your method, all of that needs to be submitted along with your method, because I need to have a look at those to make certain that they're appropriate for use and that they aren't going to result in any major errors that are going to give you a problem when it comes to doing data analysis. So just be sure that you know those important dates are coming up. All right, so our objectives for the experimental research strategy, this is inclusive of both parts 1 and 2, is to understand in more detail the goals of the experimental design strategy. Okay, you already know that determining cause and effect is one important goal. But you should also be aware that differs from correlational designs and also descriptive designs that are coming later in the semester. Also be able to describe threats to the validity of an experimental study and discuss their potential remedies. This is also a topic that's discussed in chapter 6 of your text. way back when we were talking about defining and measuring variables, we talked about a type of validity called external validity. Another word for which is generalizability. So we talked about how well the findings from your study can be applied outside the confines of your study. Well, when you talk about the experimental strategy, it's important to understand that a different sort of validity, which is kind of the opposite of external, is going to come into play, and that is internal validity. You don't know what that is yet, but you will. And once you know what it is, you'll understand what things can happen in a study that weaken that internal validity and how you can remedy that. We'll talk about the rationale of using a control group. As I said in the introductory slide, a control group is not a requirement, but they are frequently used in experimental studies for good reason, and so you need to understand the rationale behind them. You also need to understand the difference between different types of control groups. Specifically in psychology, we have a no treatment control option and a placebo control option. What do those do for us? When would we use them? What's their logic and rationale? That is yet a third objective. We'll also discuss a concept called a manipulation check. And then also understand the differences between subtypes of experimental research called process research and outcome research. And here's our overview. An introduction to experimentation. We will go over the required elements of an experiment, discuss internal and external validity both, and then last we'll discuss subtypes of experimental designs called between groups designs and within groups designs. You might be a little bit familiar with those already from your statistics courses, so hopefully that will be familiar ground for most of you. All right, so introduction to experimentation. First, a little bit about terminology, okay? So when you hear the term experiment, most times people are referring to something that is often thought of as a true experiment, okay? Now, that is distinguished from something called a quasi-experiment. We're going to get into the definition of a quasi-experiment later. However, suffice it to say for now that a true experiment, or just an experiment, is really kind of considered the cornerstone of research in all scientific disciplines. It's kind of the holy grail. And as I've kind of beaten into your head so much by now, that's mainly because it gives you information, the most amount of information. It gives you information about the mechanism behind the relationship between variables, the cause and effect relationship, okay? Quasi-experiments do not do that. So true experiments do, because they meet all the requirements that we're going to be talking about in a couple of slides. Quasi-experiments fail to meet all the requirements. So when you hear the word experiment, that is generally referring to a true experiment, although also note that there is a type of design known as quasi-experimentation that we're going to be talking about in a little bit. In experiments, of course, we are looking for causes, and experimentation is the only research strategy that allows this. It cannot be shown simply through the measurement of variables, which is what happens in a correlation. As a result, in experimentation, we are looking at changes in one variable and examining whether those are due to changes in another variable. So whenever I say this part of the lecture, I always think of like a person that's like a puppet master, someone playing with marionettes where they're pulling the strings. We're looking to see if we pull this string, what happens to the puppet? If we pull this string, what happens to the puppet? So we're sort of breaking down that mechanism of cause and effect by using experimentation. To achieve this, manipulation of one variable, the string, and observing the effects on the other, the movement of the puppet, you necessarily have to rule out other explanations, okay? So in other words, if I'm proposing that pulling this string is moving the puppet's leg, I have to rule out other explanations for why that puppet's leg might be moving. It seems like a ridiculous analogy, but you want to make sure that, there's not a draft that's blowing the puppet's leg around. You need to make sure that you are isolating the string as the only possible explanation for why that puppet's leg is moving. I sound like a crazy person, but I hope you understand the analogy, right? You have to rule out other possible explanations such that the only remaining explanation for changes in your dependent variable is what has changed under your control with the independent variable. Okay, so alternative explanations for changes in the dependent variable must be ruled out. Okay, here's another example that's not as silly as the puppet example, okay? Let's say I have administered test 3 to you guys over whatever material was covered in test 3. And I see that you have better grades on test 3 than you did on test 2. And I suspect that the cause of this is because you studied harder. I think you studied harder for this. However, what other explanations would need to be ruled out for the as causes for the improvement of your grades? Like, what are some other things that might have caused your grades to improve that didn't involve the fact that you studied harder? Okay, think of a couple things right now. Before I tell you, you could probably brainstorm some on your own. Okay, here's just some things I thought of. Maybe the material was easier, right? Could have been that test 3 stuff just was overall easier, not as complex or not as challenging, okay? Could be the way that it was taught. Maybe I used more effective teaching methods with test number 3. It could be environmental conditions. Maybe you guys took test 3 under conditions of better lighting, or maybe a quieter, less noisy environment. Or maybe you had more time with less distractions when you were taking test 3. Or perhaps by the time test 3 rolled around, you were a little more familiar with the test format and you kind of knew what to expect, okay? All of those are competing explanations for that outcome variable, which is test scores, okay, that must be ruled out before I can definitively say that the reason was that you studied harder, okay? All right, so a few little minutes to discuss some of the terms that we're using just to make sure that you understand them completely, okay? So remember we talked about the definition of a variable way back when, the beginning of the semester. Well, a variable is a trait, a quality, a characteristic, an event, something, really anything, that has 2 or more levels, can change over 2 or more levels. That means it can adopt qualities or quantities that are in 2 different levels that can be represented numerically. So as I was talking about in the introductory slide, let's say you have 2 different conditions of hand position, one in which hands were free, one in which hands were restricted. I can denote people who had free hands by giving them a 1, and I can denote people who had restricted hands by giving them a 2. So that's a nominal variable. The 1 and 2 is meaningless other than that identifies which group each participant was in. So a variable is trait, quality, characteristic that can change over 2 or more levels. It is the creation of those treatment levels in the independent variable that allows you to manipulate it. The creation of those treatment conditions is what allows you, that is the manipulation of the independent variable. So we created the 2 treatment conditions, hands free, hands restricted. That was what allowed us to manipulate hand position as the IV. Here's another example for you. Remember that article that we read comparing Certindol, okay, Certindol to Haldol. And so the type of medication was the independent variable, okay? And that had two levels. This is a qualitative manipulation. Half the participants received Certindol and half the participants received haloperidol. Those are the generic names for those medications, and sometimes I lapse into talking about them with their trade names, which is Cerlect and Haldol. And I'm not sure if I ever told you the outcome of that medication, because I think maybe I did tell you, but I'll tell you again. I went and looked it up, and Cerlect never came to market. It was associated with adverse heart events, so it never was cleared, and it was never used, and it never became available as an antipsychotic or treatment for schizophrenia. Okay, so they had the patients receiving Cerlect and the patients receiving Haldol. And again, I'm not sure how many were in each treatment condition, but let's say now we have 30. We have patients 1 to 15 here, and patients 16 to 30 here. So we have 15 participants in each condition. So our IV is type of medication. We have two different levels. And note, this is kind of interesting, note in this example, there is not a control group. We're going to revisit that issue, but there's just two levels. It just requires two or more. And so we have that basis of comparison, comparing the Cerlect receiving schizophrenics with the Haldol receiving schizophrenics. And the outcome variable, or the dependent variable, in this case, we're comparing means, running out of room here. Okay, was treatment failure, time to treatment failure, remember? So I will abbreviate that TF. TF. And they operationalized treatment failure in 3 different ways. If I remember right, it was it being readmitted to the hospital, discontinuing the medication, or a higher score on that psychotic symptom rating scale. And the DV was actually timed treatment failure. So in this instance, they would hope that the time to treatment failure for Cerlect would be statistically significantly shorter or lower. That mean would be way lower than the time to treatment failure for those patients taking Haldol. Okay, so in this case, they created these different treatment conditions, they manipulated type of medication, and they had 2 levels, which were the values of those 2 different conditions, however many milligrams of Cerlect, however many milligrams of Haldol. So the dependent variable, of course, as I just illustrated, is that variable that is measured. Sometimes it's called the outcome variable. It's the one that's observed. So exactly what we've been talking about is what we're looking at here. We want to know if the strings that we're pulling, which is the type of medication, is impacting the movement of the puppet, which is the treatment failure. Okay? And so in order to do that, we're going to be required to rule out all possible extraneous variables. What are extraneous variables? Well, remember when I was telling you that all other competing explanations must be ruled out. All of those other competing explanations are considered extraneous variables. So in the example of a study where I was wanting to know the cause of your improved scores on test 3 relative to test 2, in order to rule out all other explanations besides the fact that you studied harder, I would have to hold or exclude all of those other variables that I mentioned, like that the material was easier, or the techniques I used to teach you that material, or the environmental conditions like the lighting or the noise or the time, your familiarity with the test structure. all of those other competing explanations would be considered extraneous variables, and they must be ruled out such that in the end, I know the only possible cause is the independent variable. Now, there's a lot of different ways to rule out extraneous variables, which is why I'm not delving into this too deeply right now, because there's a lot of different strategies for doing that. Let's think for a moment about this little example I gave you up here where we varied type of medication. What might be some extraneous variables that might play a role in treatment failure that did not involve the type of medication that the participant was taking? I'll let you think about that. I'm sure that you can come up with some. I can come up with many on my own, but I'm not going to tell you because I want you to come up with them. And with that, we're going to conclude part 1A, and I will pick up with extraneous variables for part 1B. Have a great day.